83 first because I haven't answered all those questions yet, have I? Have I already answered those? On page 89 and 90. No, you didn't answer the night before. Okay. 53 and 52 or 52 and 53? Just kidding. Okay. Okay. 53 definitely. So let's start there. Value Park charges $1.10 per hour. If you ever see per, we're thinking rate. Okay, that clues us in rate. I probably chunked it, but I can print another one. All right, Value Park charges $1.10 per hour or fraction of an hour for airport parking, Brian. The maximum charge per day is $7.20. That's cheap. Mr. Chickering was telling me yesterday that Miss Chickering was fussing because they went to a hotel in Boston and they got the bill. They paid the bill, but then they got the itemized bill and it said parking, $10 for parking in the hotel parking lot where they. In Atlanta, and it was $20 per person. Yeah, that's crazy. But you, right? That's what she was saying is, I paid the money for the room. Why do I pay to park in your parking lot? Or just charge $10 more for the room for the night. Anyway, is it really? It's just the point of the matter. That's what she was saying. Okay. Anyway, write a formula that gives the charge for X hours between 0 and 24. Any ideas? Okay. So between 0, so this is the maximum, right? So it's $1.10 per hour. So we'll let X be the hours. So if I was writing this, I would say, how do we, because it says $1.10 per hour or fraction of an hour. So if you stay for 30 minutes, how much are you getting charged? $1.10, you're still getting charged for the hour, right? Agreed? What if you stay an hour and 2 minutes? 2 hours, right? So what's a function that I can use that takes whatever number I have and rounds up to the next integer, the greatest integer function? So but that's only, what did it say? That's only when X is, actually the maximum charge is $7.25 per day. How many hours would that be? 6 hours? So this is true when X is between 0 and 6. And actually, I think I think that I am going to have to. Oh, okay. Well, then this should, okay. Because if there's 0, then you're not saying it. Yeah, then that would still. It still plugs in and works. No. Yes, if you put 0 and you get 0. What's 0 times anything? All right, well, I'm not putting that. Okay, but here's, wait just a second because I think, I don't want to, let me look at this first. The word problem, you got to take the word. Really low. No. Oh, I believe you. I was right. Something's wrong with this. If because what does greatest integer doesn't take it from a decimal value and round up. It takes it from the decimal and rounds down. Remember, it does this. So if this is 1/2, then it would charge it for 0. So instead we need to flip it. And whenever I flip it, if I flip it up, right, I can make this negative. That's going to flip it up. But then I'm going to get a negative value. So to counter that, I'm going to just multiply by negative this.
I don't get that.
Okay.
Is it really? It's like, wow. Okay, here's what stopped me. Here's what stopped me. Greatest integer doesn't take a decimal and round up. It takes a decimal and rounds down. So that flips it over. That's like a reflection. Right. So it rounds, so rounding it down, but then to counter that, I need it to be positive because it's money, so I threw a negative in front of the other. Here and here. Okay, well, that's okay. You can use your calculator for that to graph it, but that's, you don't have to, yeah. 56. Okay. Math, and then go over to num, and it says int. On which of the following interval? Ooh, a continuity problem. On which of the following intervals is the function not continuous? Why? Why B? So where is the problem coming? We know where the problem is here. The problem's at 0, right? So if the problem is at 0, there's only one that actually includes 0 in it, and that's B, because that tells me it includes 0. It can't, 0 is most definitely a discontinuity here. So that's different from this one, right? Because it includes 0. Do you see where they were getting with that one? That was kind of a silly question. On which of the following intervals is it not continuous? We know it's not continuous when, go ahead. Right. That's correct. Right. Yeah. You wouldn't start at 0. You'd start at 0.0001. But you see what I'm saying? It would be an open dot at the end before it did whatever else it's going to do. Yes. Here. Which of the following points is not a point of discontinuity? Not a point of discontinuity. All right, so you know what this looks like, right? Slid over to the right one. It goes like that. Actually, that's included. So which one is not a point of discontinuity? At x equals -1, there is no graph. At x equals 0, there is no graph. At x equals 1/2, there is no graph. At x equals 1, there's a point. That's the only one that it could be. Can't be a discontinuity there if it's, yes. Yeah. Oh, no. But if you did, you'd see it's not even defined there, right? 0, if you look at part A, -1 minus 1 is -2. Square root of -2 is imaginary. It's not even on the graph. So if yesterday was easy, good. Anything else from that section? Let's see. So let's look at 47 first. Find the value of a so that the function is continuous, and I have this nice little piecewise. Y'all thought you were done with piecewise when y'all complained about it all the last time, though, in pre-cal and yeah. Calculus loves the piecewise. Find the value of a so that the function is continuous. So what do we know continuity means? What's the definition of continuity in terms of calculus? That's right. The left and right limit have to equal the function value at that particular point. So this is going to be my left limit. This is going to be my right. Of course, I'm talking about as I approach 3 because that's my point that's in question with continuity, right? So if I just plug in 3 to those, that needs to equal that, right? And the function value itself is where I'm included here, so it would be plugging in here. So that'll be fine because I'm already plugging in. All right, 3 squared is 9 minus 1 is 8. The air cooled off a little bit. 6a, so I divide by 6, so 4/3 would be a. Okay. Yeah. Ooh, which of the following, y'all good on that? Avery. That's okay. Okay. 58. Which of the following statements about the function is not true? All right. Well, let's just look at each one individually. F of 1 does not exist. True or false? False, because it does. That's right. Well, so that's the one. Oh, because it says which one is not true. It does exist. Right? It's defined at 1. F of 1 is 1. Anything else? Or not? Or are true? Or why the others are true? Okay, so part B, the limit as x approaches 0 from the right of f of x exists. So if I'm coming in from the right, that's coming in from the positive side, which would be from this side, right? So even though this does not include it, even though there's not an endpoint there, right, I would technically have, if I'm on the line, I'd have an open dot at 0, 0, and then I'd have 2x, 1, this is 2. That piece of that graph does something like that, right? As I come in from the right, I still have a limit. I might not be defined at that point, but I still have a limit. That limit still exists. All right, so then part C, the limit as x approaches 1 of f of x exists. Remember what that means, from the left, from the right, and the function value. So as I approach 1, this would be the left, this would be the right, this is going to be my f of 1 value. So if they all equal 1, I'm good to go. Well, if I plug in, ooh, wait, x approaches 1. Oh, I'm not talking about continuity. I'm just talking about limit, yeah. So this one doesn't have to equal. These two just have to equal each other. So 2 times 1 is 2, and then negative 1 plus 3 is 2, so that works. Now, if it said it was continuous there, then I'd have to look at the function value also. Okay. So I was getting limit definition and continuity definition, except for the limit to exist, the left and the right limit just have to be the same. For it to be continuous, that has to be true, and the function value has to be that at that particular point. Make sense? And then D, the limit as I was getting to part B apparently. The limit as x approaches 1 of f of x does not equal f of 1. That's true. Because here, the limit here was 2, but f of 1 is 1. So they do not equal each other, which means the function's not continuous at that point. The limit exists, but it's not continuous. It's got a little dot right above or below or wherever. Actually, it's below. So it actually does something like this. Whatever. But there's a that hole is filled in with a dot. 53. Don't worry about part B. You can use your calculator. Like what the graph looks like? Or how to graph it? On what, at what values of x? So x is not continuous at the integers themselves, because that's where it jumps, right? Because it does something like this. Right? So it has these jump discontinuities at every integer. That's greatest integer. That's math over the number in INT. But piecewise, really you can just graph the whole, it starts getting kind of complicated to graph, because you got to do some brackets and restrict your domains and yeah, now this is not the piecewise one. This is she went back to number 53 on this one. Okay, so that's not actually, I think your calculator is connecting the jumps. Oh, I see what you're saying, because once you hit a certain value, these are jumping, right? But then once you hit so many hours, it's going to be $7.25 no matter how many hours you stay up to 24 hours. That's what that last one is. Are you looking at the solutions? What did you graph? Are you sure? Y'all don't get hung up on greatest integer. It does not pop up that much. It really doesn't. What else? Y'all ready to flip to the next one? One through 7, y'all said was easy except for 7. Like a trig one? A trig one? 5. Okay. Let me start with 5. So this one is gray. Gray means no calculator. All right, so it's asking me to find average rate of change. Average rate of change is just the slope. That's all I'm looking for. And I'm looking at the slope for part A from pi over 4 to 3 pi over 4. So you'll probably need your little handy dandy unit circle if you don't remember your change of value. Although the over 4s are pretty easy and should be pretty easy for you, right? Why are those easy? What are the coordinates at pi over 4? Come on, y'all. The tangent is 1 because it's square root of 2 over 2, square root of 2 over 2. So tangent is 1, which means cotangent is also 1, right? Because flip of 1 is 1. Yes? Oh my gosh, y'all better learn that unit circle. Okay. Yes, I gave you another laminated one. Okay. At 3 pi over 4, I am clicked over to the next quadrant. So at 3 pi over 4, I'm at negative square root of 2 over 2, square root of 2 over 2, which means the tangent is negative 1, the cotangent negative 1. The tangent and cotangent values are not always the same, but in the case of the over 4s, they are, right? Because the flip of something is the same, of 1 is the same. Okay. All right, so now that we know that, let's find the average rate of change over this interval. Okay? So to do that, I need each value. So I need f of pi over 4, which is the cotangent of pi over 4, which we just said was 1. So if I'm thinking in terms of regular old slope from back whenever, this is x1, y1, right? And then f of 3 pi over 4 would be the cotangent of 3 pi over 4, which again, well, actually negative 1. So again, x2, y2. So if I want average rate of change over this interval, well then, it would be 1 minus negative 1 over 3 pi over 4 minus pi over 4. That's just slope. Oh, I got it backwards, didn't I? Sorry. There you go. All right, so I get 2 over negative 2 pi over 4. Don't divide by a fraction. Instead, multiply by the typical. So I get 2 times 4 over negative 2 pi. Negative 4 over pi. Do what? Top and bottom. Or you say 8 divided by negative 2. Either one. This is a no calculator. What did you need? Why did you graph it? For what reason? Oh, and you used the table. Well, what about on part B whenever they weren't even values? So like part B, oh my gosh. Oh dear. All right, let's think about it pi over 6. At pi over 6, what are my coordinates? That's the very first click up, right? Whenever I'm on my unit circle, I go 0, pi over 6, pi over 4, pi over 3. So at pi over 6, what are the coordinates? Which one comes first, 1/2 or square root of 3 over 2? It's further over, so it's going to be square root of 3 over 2, 1/2. I'm trying to show you this way so that if you don't remember how you can come up with it. What's the tangent value then at pi over 6? Square root of, because we do sine divided by cosine. So 1/2 divided by that, which is times the reciprocal. Right? Which means that cotangent is the flip of that, which is just the square root of 3. This is stressful, Lainey says. Stressful. At pi over 2, what are the coordinates? 0, 1, which means the tangent value, undefined, but the cotangent is 0. Cotangent is cosine over sine. Tangent is sine over cosine. Say that again. Yeah. You just have, listen, if you can't think it, I've always been one. I'm not a memorizer. I have to reason through things. I don't have the unit circle memorized like that, but any point you give me, I can figure out what it is. It takes me just a little bit longer. Some of them I know like that, but some of them I have to really think about for a second. Well, you better be one of them, Robert. Great day. We're going to do a Kahoot. We're going to do a unit circle Kahoot. Not today. Not right now. Maybe if we have time at the end. What do y'all keep looking at? Somebody out there? What are they doing? Huh? A strange man on this interval. Y2 minus Y1 over X2 minus X1, or vice versa. Remember, I'm talking about cotangents. So I'm doing f of pi over 2 yes? And since I don't have a calculator for this, the cotangent of pi over 2 is 0. Oh my gosh, number 5, part B. F of 6 would be square root of 3. And now I've got to do pi over 2 minus pi over 6. I'm going to times by 3, times by 3. So 3 pi minus pi over 6 would be 2 pi over 6 to get a common denominator. I'm so glad you're in here to say those things. She said your hair looks nice today. So this would be negative 3 root 3 over pi. This would definitely be a non-calculator problem, especially considering one of the unit circle values was pi over 2, which is one of the easiest ones. It is not going to give you a pi, Robert. Robert, or a square root of 3. That's an irrational number. It's not wrong. All right. Learn your unit circle.
I got it.
Okay. What else on that homework? The trig functions. The trig. I did a terrible job making y'all learn the unit circle, apparently. You did not know it last year. There's no way you... Okay, there's no way you knew it, but then you can't even remember what pi over 2 is. No. I know. That did not help y'all in pre-calc clearly. All right, what else from your homework? Oh my gosh, that's okay. So, all right. Yes. 7 is very important, actually. In fact, let's take a break in between and let's start the new lesson with number 7 because it's going to lead into what we're talking about today. Because it's tanning. It's actually tangent lines. What's wrong? I'm teaching, Robert. What are you doing? Why don't you just take a little break and learn that little unit circle? Come back to us when you... What are you confused about, Avery? What's wrong? It's probably intro to tan lines. Something along the... Yeah. right, so yesterday you did some AROC type problems, right? And right before I left, I defined something called a secant line. You remember what that was? It goes through 2 points on the graph. Goes through 2 points. And so whatever my curve is, a secant line, like this, would intersect in 2 places, right? This is a secant. And so when you find the average rate of change, what you're doing is you're finding the slope of that line between those 2 points. Yes, if you do, all right, if this is A, this is B, this is C, this is D. If you do the slope here, the slope between those 2 points, what you're really finding is the slope of the line that connects those two. So you're finding the slope of the secant line. Is everybody okay there? Secant intersects the graph in 2 places, 2 points. Are you with me? Any type of graph that I have, if I have a quadratic, that's a secant line. I was just saying that the average rate of change is the slope of the secant line. Slope of the secant is equal to AROC. On that interval, whatever those 2 points are. It's the same you did on 1 through 6, okay? We're just kind of giving it some new terminology here, but you already know what to do, right? You already understand what you're finding. Now, it's important that we understand that this is a line and what kind of line it is, because now we're going to talk, calculus focuses in on the tangent line. Now, what does it mean to be a tangent line? It intersects at just 1 point. Intersects. This is where we're trying to get that h value to be 0, right? So it comes here. This is tangent to the graph. It intersects at only 1 point. It just touches that 1 point, and that's it. Okay? So when we start talking about a slope of a tangent line, that's where when we were talking about getting the points closer and closer and closer together until there was no space between them. Remember, that's whenever we did that, as we tried to get that limit as h went to 0 of that big long equation we did. Y'all know what I'm talking about? I'm giving you the background. You know, I'll give you examples and just tell you how to do it before, but I like to give you the connecting information first. If you don't understand, it's okay, because I'm being extra right now. Okay. Tangent line intersects at 1 point. To find the slope of the tan line, I'm trying to put these secant points closer and closer together. Like this is a secant line, yes? As I move these points closer and closer together, I get closer and closer and closer to the slope of the tan line. Do you see that? So the closer I can put my points on my secant line, the closer I approach the value of the tan line slope. Does that make sense? Because the tangent's intersecting and that's where I get into that. Do you remember whenever we did f of x plus h minus f of x over h? And we said if we could get h to be 0, that would be ideal. We can't, so we take the limit getting closer and closer to 0, right? Same concept. This is just the slope of the tan line. That's what we're doing. Okay? But we're going to do it at specific points. Okay. Let's do this. You're saying no, and I hadn't done it. Why are you saying oh? Let's take a very basic graph. Yes? All right, that's the parent graph, right? What if I asked you to find the slope of the tan line at some random point? Let's say the slope at the point 2, 4. And better yet, what if I didn't just say slope? Well, let's start with slope. We're going to write the equation of that tangent line, but first let's focus on the slope. How might I find the slope at the point 2, 4? So you're getting close, huh? But it can if I'm okay, so let's think about this graph. Here's this parabola, right? This is the point 2, 4. So what I'm asking is the line that touches just this point, what's the slope? Huh? Yeah, at 2, 4. A tan line. So we're not going to just guess. Okay, let's go back to that formula that we learned back on in the very beginning, right? Where we said at a specific point, what we want to do is we want to do the limit. We want to get the distance between the 2 points to be 0, right? X I know, right? I know I want it to happen at 2. It's the h that I don't know. I want the h to be 0. I want the slope at exactly that point. What? Well, what I'm going to do, remember I told you star that, circle that, highlight it. That was a very, very important formula. This is called the difference quotient. It represents the slope of the tan line. You will see it many times. It will have an A in here instead of an X, and it will say at the point X equals A. We're going to leave it like this right now, though, and we're going to say, okay, if I'm at 2, right, because this is 2, 4, right? So that means f of 2 is 4. Do you agree? F of x is x squared. What is f of x plus h? Y'all can do this. This, right? But if I asked you for f of 4 plus h, because if I wanted, not 4. You'll see what we're doing. I'm looking back at this original function. Everything comes back to that original function that I defined. Okay? So what I'm asking you now is, what would the slope be when x equals 2? So use this equation that we have. The limit, I know that the slope is going to be when there's no difference between the points. That's going to give me that exact point, right? If you're just a, Miss McGee, just give me the formula and tell me what to plug in where, then this is where you need to start listening, right? The limit is h goes to 0. And I'm just going to plug in here. What is f of x plus h? X plus h squared minus, what is f of x? X squared over h, right? But I asked you at a specific point. So what I'm going to do is I'm going to take this 2, because that's the x I asked you, and I'm going to plug in a 2 here for the x's. Go with me? And I absolutely did. And I'm fixing to manipulate it some more, because remember when limits, when I have that h in the bottom, I need to do something algebraically to get that 0 gone from the bottom so that I can plug in and substitute. It's just another limit problem. So now in the limit, as h goes to 0, 2 plus h squared minus 2 squared over h. How can I evaluate that? That's right. I can expand that. This would be a FOIL problem, right? The limit is h goes to 0 of 4 plus 4h plus h squared minus 4 what happens? Go do the 4's first, right? 4 minus 4. Now I got the limit as h goes to 0 of 4h plus h squared over h. What do you notice everybody has? An h. I can take out an h. Remember, this is just going back to those limits where we're just keep on working what we can until it gets to where we can plug it in. So it's the same thing. The limit as h goes to 0 of 4 plus h. Can you substitute in now? Yes. And you also have to take one away from here. Think about it like this. If you factor an h out of the top, otherwise you'd be killing a kitten. You can't just do this without taking it from that one also. In this case, but what if h was 1? What if h was going to 1? Yeah. So now I can substitute in 0. So my goal the whole time is getting it to where I can sub in. These are always going to work out this way for right now, by the way. Okay. So that was a lot of work, but yeah, go ahead, Robert. There would be a different equation in here. Yep. Yes. I would have to keep manipulating it until I could get it to a point of plugging in 0 for h. We'll do another one with a different equation. What, the x squared? Yes. But this is the step what's circled in green is always, always, always what you use to find the slope of the tan line. What's in red below that, this one, is specific to that function. Do you see what I'm saying? This is general. This is specific to the problem. Because the problem said f of x was x squared. So that's why I've got all these in here. Yeah. Right here. Foiled out 2 plus h. Y'all don't be scared to ask now because this is big. This is big. This is huge. No, it is big though. All right. Now, what does this tell me? What was I finding to start with? Go back. This was the slope of the tan line when x equals 2. And that is 4. Well, oh, well, this is nothing yet, buddy. Just wait. Because I don't know, I find them very satisfying. That's right, it is. I love a puzzle. What? You don't have to, but it's just, that's just, you'll see it a lot like that. You'll get used to it. All right. Oh my gosh. Okay, but look, this is not the only thing we're looking for. This is the slope of the tan line. What if I asked you to write the equation of the tan line at the point 2, 4? Now we got to go back to algebra 1, right? To write the equation of a line. Okay, so, and this is huge. Okay, equation of tan line. This will come up even once we are into integrals at the end. We will still, you'll do this so many times, this will feel like, this is like the factoring of Algebra 2. You know how Algebra 2, you factored in everything you did after you learned to factor? That's what equations of tan lines are in here. You will use equations of tan lines for it. All right, equation of the tan line. To write the equation of a line, you need what? Slope and a point, right? I mean, just basic. Not this particular one, but any line in general. To write the equation, you need a point and a slope, right? Y'all remember point slope form? That's slope intercept. This is going to be your best friend, is point slope form. Point slope form. It takes a point and a slope, right? And now it's bad. Now, I asked you, huh? Wasn't? Okay, well this is easy. This won't be hard. If I asked you for the equation of the tan line, this is the slope of the tan line. And this is the point that was given to you for that tan line. In other words, they gave it to me to start with. They said the point was 2, 4. There's my point. And then I just found the slope. It's just a plug-in problem. So the equation of the tan line, I should say at a point. The equation of the tan line at 2, 4, because the equation is going to change depending on where you are on that curve, right? If I'm here, this tan line is a lot different than if I'm down here, okay? So the slope, the equation of the tangent line at the point 2, 4 would be y minus 4, slope x minus 2. And the only thing calculus does is they generally will leave you solve for y at the end if it's a multiple choice question. So they would have this way. Not even multiplied out, not even anything else but in that form right there. That is the tan line at 2, 4. What do you think? Yes. Huh? You what? Is it factored? Yeah. You can leave it just like that. No, just leave it. Don't ever. So the good thing about calculus, especially on the not any of them really, if never try to simplify more than you have to. I know in Algebra 2 we drilled simplify. Don't do that here, because at the end of the day, if you simplify wrong, you lose your answer point. But if you leave it unsimplified, anything like this, I would stop. If you have something, the rule of thumb, if it's a specific answer, if you could type it into a scientific calculator and get an answer, you can leave it like that. So if I had something like 1/2 times 3 to the 4th minus the log of 7 over, I don't know, e to the 5th, it's acceptable to leave it that way. Yeah. No, I'm talking about if you had your calculator, don't plug it in and try to get a decimal for that, because you might plug it in wrong. Just stop. Leave it like that. Anyway. Okay. The request was to do one from the homework. We'll just start with, okay, we've already done, yeah. That is a lot of the goal, yes. It says find the equation of the tan line at the point. Yes, that is the equation of the tan line at 2, 4. Oh, no, the general formula is here. That's the slope of the tan line. That's, okay, so that's the equation of a line. That's point slope of a line. That's in general, yes. You'll always use that. Yes, I'm sorry. Yes, 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 yes. Any line. Hard or easy? Well, what kind of example do you want? A hard one or an easy one? Yeah, this is number 11. Find the slope of the curve at the indicated point. Then find an equation for the tan line at that point. We haven't done the normal line yet, but let's start. All right, find the slope of the tan line when x equals 2, and then find the equation for the tan line. All right, so let's think about our equation, right? For the slope of the tan line, I do the limit as h approaches 0, f of x plus h minus f of x over h. Yes? Okay. But I'm plugging in 2 for x, right? All right. So I'm going to do the limit as h approaches 0 of f of 2 plus h minus f of 2 over h. Sometimes I find it convenient to come off to the side and work out my f of 2 plus h or my f of 2 so that I don't get lost in my problem. But however you want to do it is fine. I'm fixing to. I haven't yet. Right now I'm just, this is how I do it. So right now what I want to do is, what is f of 2 plus h? Because that's what I need to know here. Well, f of 2 plus h is 1 over 2 plus h minus 1. Do you agree or disagree? Go back to your original equation, right? What is f of 2 plus h? Plug in a 2 plus h for x. You got what for the slide? I don't know. I haven't worked it. Oh, I don't have an answer. I don't know. So now I'm going to put those in my equation and start manipulating and see what happens. So I'm doing the limit as h goes to 0. F of 2 plus h is 1 over h plus 1 minus f of 2 is 1, and everybody goes over h. I remember f of x is 1 over x minus 1. So if I do f of 2 plus h, then 2 plus h will go in for the x minus 1. Okay, so several ways I could go about simplifying this. If I'm doing this one, I am going to look at this one and say, okay, well, this is just 1, so this is really h plus 1 over h plus 1. I'm going to simplify the numerator first. Is that what you did? All right, okay. I gave them common denominators. So that now I have the limit as h goes to 0. I'm going to combine the tops, right? 1 minus, and I have to subtract all of this, 1 is the same thing as h plus 1 over h plus 1. I forced them to have the same denominator. So now I combine the numerators over that common denominator. This is tough, y'all. This is one of the tougher things, manipulating difference quotients. We learn a shortcut later on, but you haven't learned it yet. So, because it's so, difference quotient is so heavily tested. All right. Up top, I end up with negative h. And what I'm going to do is go ahead and multiply by the reciprocal. Remember when we did complex fractions, top, bottom, together? Kind of the same kind of thing here. And then I'm just going ahead and doing the together part. Top times the flip of the bottom. Well, because this, since you're subtracting all of this, it's really 1 minus h minus 1.
Why? How did you get rid of like
The top denominator?
I don't know how to explain it. There's like 2 fractions.
How did I get rid of what? Ask me again. Okay, so the h, this below. This one. Okay, I didn't get rid of it. It's right there.
Oh, wait. Oh, you're multiplying by the reciprocal.
Yes. This is the denominator. This was here, and now I'm multiplying by the flip of it.
I still don't understand how much.
What? But that, right, that is 1 minus h minus 1. That's 0, which leaves me negative h. Y'all with me now? See, it's not the calculus. It's everything else. The calculus is just the limit as h goes to 0. The algebraic manipulation is what's killing y'all right now. All right, I'm still not done. If I am multiplying fractions here, right? This is like one big fraction. Would you understand if I went ahead and marked this out? Okay. The h in the top and the bottom. That leaves a negative 1 in the top. What's left in the bottom? H plus 1. Can you plug in 0 for h now? Because that's been my goal the whole time. Getting it to where I can plug 0 in. Yes. So now if I plug in a 0, I get what is the slope of the tan line when x equals, I forgot what I even plugged in to start with 2. Well, the question was, I mean, you could just put slope equals negative 1. You just don't. So now we write the equation. So we're writing the equation of the tan line at x equals negative, no, it wasn't it. I mean, at x equals 2, right? They didn't give me a whole point this time. Remember, to write the equation of a line, I need a point and a slope. I have a slope, I need a point. How do I find the other part of the point? Put 2 in, go back to that original equation. I need to know what is f of 2, which I technically already found within this one, right? It's 1. Up here at the top, I had already found f of 2. Now write the equation of the tan line. So your point here is 2, 1, and your slope, so y minus y1 equals slope x minus x1. And just throw that 1 over on the other side. I'm probably not giving you that many, honestly. Okay, tonight, here's what I want you to do. Y'all have page 98 on that thing, right? Oh no, we haven't got there yet. That's it.